Hello, everyone. In this video, we're going to talk about strong acids and how they're different from weak acids. So strong acid is any acid that ionizes or dissociates 100%. So what happens to a strong acid, for example, in the case of HCl, is that it 100% it turns into ions. So it right away turns to H plus ion and Cl minus ion. So the easy thing about it is that once you know the original concentration, now, based on stoichiometry, you can find a concentration of ions in there. Because it's 100% ionizing, that means it 100% turns to H plus and Cl minus, and right away you can find the concentration of those ions. Whereas when you have a weak acid, let's say, for example, CH3COOH, what happens to it is that it only partially ionizes. So it can be 1%, 2%, less than 1%. So it depends. So to find the concentration of ions, you have to basically do an ice table for doing the calculation. So this turns to H plus and CH3COO minus. But let's say if the original concentration is 0.1 molar, eventually after doing the ice table, you have to find the equilibrium concentration of these two ions, which is going to be very small relative to the original concentration. So how do we know how to identify between a strong acid and a weak acid? So there's essentially 6 strong acids that we need to know of. So they are HCl, HBr, HI, HNO3, HClO4, and H₂SO₄. So these 6 acids are the only strong acids that we have. Any other acid is going to be a weak acid. So for a strong acid, as I said, they will always make you H plus and Cl minus, or sorry, in this case, it's going to give you Cl minus. It's going to make you H plus ion. And then same thing, weak acid is going to make you H plus ion as well. The difference is the strong acid will 100% turn to ion. So it will be 0.1. If you start from 0.1 of this, it would be 0.1 for H plus and 0.1 also for Cl minus. So same thing. Let's say we have another acid like HNO3. So in the case of HNO3, again, same thing, because it's a strong acid, it will 100% turn to ions. So it will give you H plus ion and NO3 minus ion in this case. So if you have, for example, 2 molar concentration of H plus, HNO3, it will be 2 molar H plus and 2 molar NO3 minus as well. Now, the only one that it's a little bit tricky is H₂SO₄, because H₂SO₄ is a diprotic acid, meaning it has 2 hydrogens to give away. And what it does is that it cannot give away both of the hydrogens at the same time. So what it does is in the first round, it will lose the first H plus of it. So it will give you H plus and HSO4 minus. So let's say if I have 1 molar H₂SO₄, then this is going to be 1 molar and this is going to be 1 molar. But then when it gets to the second ionization, when it loses the second proton, then it's going to be a weak acid. So to solve for the concentration of H plus, you actually have to carry a nice table for that. So this will give us H plus and SO4 2 minus basically. So here, let's say we figured out that the concentration of H plus was 1 molar and HSO4 minus was also 1 molar. So when we carry the ice table, we have to start with 1 molar HSO4 minus and 1 molar H plus, and then this is going to be 0. And then we do the negative X, positive X, positive X. And now using the Ka of HSO4 minus, which is the K equilibrium constant for an acid, then we can say Ka is the concentration of products over concentration of the reactants, which in this case is just HSO4 minus. So it's going to be X times 1.0 times plus X over 1.0 minus X. And then this way, eventually you can solve for X. And then you can say that the concentration of H plus, once you find X, is going to be 1.0 plus X. And then the concentration of SO4 2 minus at the end of this dissociation is just going to be X. I'm not going to get into the details of solving for this because then it falls into a weak acid calculation. But just so you know, for all the strong acids, the ionization is 100%, except for H₂SO₄, because it's diprotic, it can happen in 2 rounds. First round is 100% because H₂SO₄, it loses the first hydrogen the first proton basically right away, but then the second one, it's a weaker acid. So in this case, this is a weak acid, whereas here was a strong acid. So you need to do a nice table to figure out how much H plus ion you have. So and eventually using the Ka, you can find the concentration of both ions in the final solution. Okay, so that was it for this video. I have another video that it teaches you about the weak acid, so I'm going to tag it over here. Hope to see you in the next one.